Hi everyone, welcome back to my channel. Today our topic is Laplace transformation. This lecture mainly consists of three parts. So first we will discuss about the definition of Laplace transformation. Then in the next part we will see some examples where we try to find out the Laplace transformation of basic known function such as polynomials, exponential, trigonometric functions, etc. And in the last, we will discuss some basic properties of Laplace transformation. And at the same time, we will discuss about inverse Laplace transformation. Laplace transformation are named after the famous mathematician Pierre Simon Laplace. Now let us discuss the definition of Laplace transformation. So let ft be a function of t. So let ft be a function which is defined on the interval 0 to infinity. Then Laplace transformation of ft is defined as fs, or Laplace transformation of ft is 0 to infinity, integral 0 to infinity e power minus st ft dt. So provided the integral exists. So Laplace transformation of ft is defined as integral 0 to infinity e power minus st into ft dt. So now look at some examples. So, so the first very common example is the constant function ft is equal to 1. Then what is L of ft? 0 to infinity e power st, and in place of ft we'll write 1. So it will be 0 to infinity e power minus st dt. So note that this is an improper integral. So this integral can be written as limit x tends to infinity 0 to x e power minus st dt. So if I solve the integration, we get limit x tends to infinity. We have e power minus st by minus s x to 0, which will be limit x tends to infinity e power minus sx minus 1 by minus s. Now, note that when s is positive and x tends to infinity, so we have sx tends to plus infinity. So e power minus sx tends to 0. So the limit will be 0 minus 1 by minus s. So it is nothing but 1 by s. So we can say that Laplace transformation of 1 is 1 by s. So we can say the inverse Laplace transformation of 1 by s is 1. Okay. Now next example. So example number 2. f of t is equal to e power h. So Laplace transformation of e power at is 0 to infinite e power minus st into e power h. So we can write this integral as 0 to infinity e power minus s minus at dt. Okay, so since this is an improper integral, so we can write it as limit x tends to infinity 0 to x e power minus s minus a t dt, which is again limit x tends to infinite. So the integral will be e power minus s minus a t by minus s minus a at x and 0. So it is nothing but limit x tends to infinite e power minus s minus a x minus 0. So the e power 0 is 1 by minus s by. Now here again note that if s is greater than a, then s minus ax is positive. So e power minus s minus ax tends to 0 if x tends to infinity. So this limit will be 0 minus 1 by s minus a. So it will be 1 by s minus a. So we get Laplace transformation of e power at is 1 by s minus a for s is greater than a. So inverse Laplace transformation of 1 by s minus a is nothing but e power h. Okay, the third example is we will not solve this, but we will state the formula. So Laplace transformation of sin at is nothing but a by a square and Laplace transformation of cos at is nothing but s by a square plus a square. Now we'll state a property of Laplace transformation which is very important. So the property of Laplace transformation, which is Laplace transformation is linear. That means Laplace transformation of C1 ft plus C2 g of t is same as C1 Laplace transformation of ft plus C2 Laplace transformation dt. Okay, so proof is very easy. So left hand side part is nothing but 0 to infinite e power minus st times C1 ft plus C2 gt dt. So now we know that this integration is linear, so we can write it as C1 times 0 to infinite e power minus st ft plus C2 times 0 to infinite e power minus st gt dt. So this is nothing but C1 L of f plus C2 L of gt. So Laplace transformation is linear. So similarly, we have this inverse Laplace transformation is also linear. Inverse. That means Laplace inverse of C1 Fs F1s plus C2 Fa F2s is same as C1 Laplace inverse of F1s plus C2 Laplace inverse of F2s. Okay, so that's it for today's video. If you like the video, then please like, comment, and subscribe.